Hi everyone, welcome back to our channel. In today's class we are going to discuss about commutative property of rational numbers. In the previous videos we have already discussed closure property of rational numbers. So today's video we are going to discuss about commutative property. Under addition, under subtraction, under multiplication, under division we are going to check it is possible or not. Okay, so what is commutative property? Tell me. In the previous classes in 6th class and 7th class we discussed commutative property of whole numbers and commutative property of integers. Now we came to rational numbers. So you already know what is commutative property. Means commutative property states that there is no change in the result by changing the order of the numbers. Okay, by changing the order of the operation. So if we take commutative property under addition, if we add these two, a plus b, we are changing the order of the numbers a comma b to a plus b to b plus a. So we are going to check the result is same or not. Okay, so if we take LHS, by taking example, a is equal to 2 by 3, b is equal to 1 by 7. Okay, so minus 1 by 7. You can take positives or negatives. So I am going to check a plus b, LHS at first. So 2 by 3 plus minus 1 by 7. So these fractions I am going to convert this as plus into minus 1 by 7. So these fractions are unlike fractions. I am going to convert these to like fractions. So then only we can add or we can subtract. Okay, so first fraction with second fraction denominator and second fraction with first fraction denominator I am going to multiply. 2 7s are 14 by 3 7s are 21 minus 1 3s are 3 by 3 7s are 21. So now these fractions are converted to like fractions. 14 minus 3 means 11 by 21. So this is LHS. I am going to check RHS, that is b plus a. I am going to check RHS, that is b plus a, means b means 1 by 7, minus 1 by 7, b means minus 1 by 7, plus a means 2 by 3. Okay, same process. So first fraction multiplying with second fraction denominator and second fraction multiplying with first fraction denominator, that is 7 by 7. So we will get what? So minus 1 3 is a 3 by 3 7 is 21 plus 2 7 is 14 by 3 7 is 21 we are getting. Okay, so plus 14 minus 3. Okay, so what we will get? 14 is a bigger number, is having positive value. So I am going to subtract bigger number to smaller number, that is 14 minus 3 we will get 11. So 11 by 21 as usual. So bigger number is having positive sign. I am going to put positive sign here. Here also positive sign, means 11 by 21, 11 by 21. We are getting the LHS equal to RHS, same. So LHS equal to RHS we got. So by this we can generalize that commutative property under addition in rational number system is possible. Okay, now we are going to check closure commutative property under subtraction. Okay, under subtraction. Okay, so same method we are following which we followed to addition, we are going to follow to subtraction also. So a comma b belongs to q. If we assume a comma b belongs to q, so a minus b equal to b minus a or not, we are going to check. If the rational number system follows this condition, then we can generalize that commutative property under subtraction is possible in rational number system. So for this I am going to check LHS, taking examples a equal to 2 by 7, b equal to 5 by 2. Okay, you can take any fractional numbers. Why? Because in general numbers we already discussed. So this is little bit of confusion to all the students. So I am going to take fractions fractional numbers. A minus b, I am going to check 2 by 7 minus 5 by 2. Okay, so these fractions are unlike fractions, that's why we can't subtract from one to another. So I am going to convert these unlike fractions to like fractions. For this purpose, I am going to multiply first fraction with second fraction denominator, second fraction with first fraction denominator. So what we will get, 2 2s are 4 by 7 2s are 14 minus 5 7s are 35 by 2 7s are 14. Now these unlike fractions converted to like fractions, so we can subtract directly. So if you observe these two, 35 is a bigger number, 4 is a smaller number. So 4 is having positive sign, 35 is having negative sign. So if different signs are there, we have to subtract. We are already learned. So 35 minus 4 means 31. So bigger number is having negative sign, so we are getting minus 31 by 14. Okay, so this is LHS. So we are going to check RHS now. Okay, so B minus A we are going to check. B means what? 5 by 2 minus 2 by 7. So 5 by 2. So these fractions are also unlike fractions. I am going to convert these unlike fractions to like fractions. For this, I am going to multiply first fraction with second fraction denominator, second fraction with first fraction denominator. So 5 7 ja 35 by 2 7 ja 14 minus 2 2 ja 4 by 7 2 ja 14. So now these unlike fractions converted to like fractions. So I am going to subtract directly 35 minus 4. Okay, so 31 by 14. Okay, so LHS equal to minus 31 by 14, RHS equal to plus 31 by 14. Here these two fractions are same or not? Not equal with each other. So LHS not equal with RHS. So by this we can generalize that commutative property under subtraction is not possible in rational number system. Okay, so by this we completed under subtraction. So now we are going to check under multiplication. Multiplication. Okay, so commutative property under multiplication in rational number system we are going to check. So as usual I am going to take A comma B belongs to Q. So I am going to check A into B equal to B into A or not. Okay, so as usual, for example, if we take A is equal to, tell me one fractional number. So 1 by 5, B equal to minus 2 by 9. Okay, so I am going to check LHS at first. So A into B, LHS statement is A into B. So 1 by 5 into minus 2 by 9. Okay, so multiplication is very easy. So there is no confusion. Plus into minus, minus 1 2 ja 2 by, so 5 9s are 45. Okay, so next RHS we are going to check B into A. B means minus 2 by 9 into A means 1 by 5. So minus into plus, minus 2 1 ja 2 by 9 5s are 45. So we got LHS equal to RHS. LHS equal to RHS, that is minus 2 by 45 minus 2 by 45. So by this we can generalize that commutative property under multiplication is possible in rational number system. Okay, so now we are going to check commutative property under division. Commutative property under division. So division is a little bit of confusion, so listen carefully. So at calculation only you will get small confusion. Okay, so if you know the fractions, addition, subtraction, multiplication, division, you can learn more about commutative property. So as usual I am going to take A comma B belongs to Q. So A division B equal to B division A or not, I am going to check. Okay, so as usual I am going to take two examples. A equal to, tell me any example, 4 by 7, B equal to 2 by 5. Okay, so minus 2 by 5, you can take any fraction. So I am going to check LHS at first. LHS A division B. So A means 4 by 7 division minus 2 by 5. Okay. So if I am going to keep the first fraction as usual, and I am going to change division symbol to multiplication, then the second fraction we are going to write a reciprocal of the second fraction. Okay. So now plus into minus, minus 4 5 is 20 by 7. Sorry, here okay, 7 2 is 14. Okay. So this is LHS. Now I am going to check RHS. So B division A. B means minus 2 by 5. Division A means 4 by 7. So minus 2 by 5. First fraction I am going to kept as usual, and converting division to multiplication, and second fraction reciprocal I am going to write. So minus into plus, minus 2 7s 14 by 5 4s 20. So minus 20 by 14 minus 14 by 20 not equal with each other. So we got LHS is not equal with RHS. So by this we can generalize that commutative property under division is not possible in rational number system. So by this we can generalize commutative property under subtraction, under multiplication, under division. So possible or not we are going to generalize. Okay. Commutative property, tell me, under addition is possible in rational number system, under subtraction is not possible in rational number system, under multiplication is possible in rational number system, under division is not possible in rational number system. So now we are going to end today's class. We learned about more about commutative property in rational number system. I think you understood well. If you like this video, if you think it is useful video for you and your children, please like, share and subscribe our channel. Thank you. Thanks for watching. Bye.